Okay, next up is mission course. And up until today, I had not seen anybody do as well as everybody did today. Wow. That was incredible. Mission course. Second place, Naselle Middle School. There was a three-way tie with the points at 40 points, and they had the better time, so they won that. Okay, next up was the written report category. Scored by our judges. We had 5 judges scoring. It was quite close for the top 3, but also in the written report, there was a due date of 6 o'clock Friday night. Only 2 teams made it. Other 3 didn't. Second place for the written report, Naselle Middle School. And first place, written report, Naselle Bubbleheads. Okay.
Thank you, sir. Much appreciated. Thank you, sir.
The second to the last award for the videos, and again, the judges were really impressed with everyone. This was tough. However, we did get the scoring. Second place on the video, Naselle Bubbleheads.
Thank you. Thank you.
Far left is the overall finishing, and I got told on Monday by the national folks that they will invite both our first and second place teams. Very cool. So the point values was there's only 2 points separating first, second, third, and fourth.
Wow.
Second place with 10 points, Naselle Bubbleheads. First place with 8 points, Wahkiakum Apollo 18. Your first time when your team goes, or when you're a coach on a team that goes, you've got to do something to show the kids that you care about them.
You are my sunshine, my only sunshine. You make me happy when the skies are gray. You'll never know, dear, how much I love you. Please don't take my sunshine away.
Here's the course that the kids are going to run. It is slightly different than what we've been practicing on. This first hoop that we have been practicing on has been vertical. They have it vertical the other direction, opposite. This is normal that they've been working on. This is normal. This is normal. This hoop they have changed to a 45 instead of straight. So that is throwing a challenge into them for internationals that they have not practiced. Batteries and tool hooks looks the same.
So,
Ella.
Door lever, pushing open, batteries. That all looks the same.
Naselle, Washington is a small little area in southwest Washington State, so we've come a long way. We're going to just talk about our robot as we go along with our positions. So for me, I'm the team captain, and that role kind of is about leadership. Like I've been organizing team meetings, making sure that we're kind of working on our robot because our time schedule is a little bit funky. And also, I play the role in like purchasing parts. Like we have donors, and then I use the money to purchase parts for our robot, and then piece them together. And also, at the start of our project, since as you can see, it uses a lot of electrical components. I kind of brought this home and was messing with it on my bed, and like there's wires everywhere, and I just kind of started the baseline foundation for the circuitry, and also I wrote the initial code for our robot, which is then was handed over to the responsibility of Derek. And
yeah, my main job was finalizing the electronics and the code, which you can see, this is our actual controller, and everything with the robot is controlled via here. It's all powered by an Arduino Uno, and it takes data in from this RC receiver, which then my laptop actually has a program that I wrote on it, which takes the information from the controller, encodes it, and then sends it to the Arduino itself. We originally had a problem with, we only had two of these three motor drivers, which are right here, and when we had them both left and right motor, and when we were going forward, it would split the voltage, so it would end up being slower than it could, so we got a third one to make it faster. The way that the computer sends messages, it's very primitive. It's just like, you can't send a lot of data. So I simplified it so it sends 3 characters. It sends a letter, which represents what motor it wants to control. And then it sends, the next letter is what direction it wants it to spin, which is forward, reverse, or off. And then it uses A through Z, what speed it wants to go, which is Z is the fastest, A is the slowest. And one of the problems I had was converting from a letter to a number value, which you could do with 26 if statements, but that would just be a waste of code. So I converted it to an ASCII decimal, and that's what I used as my number. Ryan can talk about how it drives.
So, yeah. So we decided to go away from the stock controller and use a hobby controller, so we could have more fine control over how fast the robot can go, I guess. So it can be more precise on picking up stuff and more maneuverability. And we also decided it would be a good idea to attempt to try to put a camera on it too, so it could be even better at picking up tools or batteries or whatever else. But it didn't really end up working out so well, because with some issues with it interfering with the motor controller throughout the wires, it was really hard to see through, as well as we kind of messed up our waterproofing on the camera too. So it kind of fried itself a little bit. So we ended up just cutting off the wires. We still actually have the camera on it, which we painted sparkly red as a little decoration. Which sadly didn't work out as well as we were hoping. As well as we thought that the zip ties that were holding the motors on were just a little sketchy, I guess you could say. Because we were scared it might fall off or something, even though I'm sure it wouldn't. But just to make sure that that wouldn't happen, we decided to 3D print our own motor mounts. That kind of goes in, screws down to make sure it's right where we need them, as well as we can adjust the motor up and down if we need to lower where center of thrust, I guess it's called, would be pushing on it, so it goes straight and not pitch up or down when you go forward.
So my job for the robot was mainly documentation. So I wrote the technical design report and did a little bit of script writing for the video. And one of the biggest things that I noticed is that we definitely should have been testing more and recording that data a lot more. So what basically happened is we were recording all of our data in like the last maybe 2 weeks, I might be a bit generous, before our initial competition. And while we had been like testing our robot in between, not actually recording that data meant that it was harder to make improvements based on what we saw, because we would just kind of forget the finer details about how fast things were that actually really mattered in the long run. And we also did, so our way of writing things was a little bit different. Yeah, it was a little bit different. So we basically wrote everything in like the last week or so. And it was fine. It was interesting. That's just what I'm going to call it. But one good thing that we did notice is that having like one person who was just working on the writing actually made the technical design report like a lot more streamlined, and the ideas in it like never got mixed up. And so in 2 paragraphs, you were never talking about the exact same thing, which I noticed through reading some past technical design reports was a real problem that some teams had.
And another little issue that we had with the robot, I guess, was being able to practice. Because we live, again, in a very small town, nowhere near a pool. So the closest pool that we could practice with a mission course was 40 minutes away. So we only practiced a decent amount, I guess. But I remember just jamming in my car and then jamming more people in the car and then just driving 40 minutes to another small town that is also here in the place, to practice and try to work out some kinks that we had, which we were working out a lot, because every single time we went there, either something broke or we had to redesign something.
Right, that's your time for presentation. Engineering design, middle school stock